Good evening, everyone, and welcome. Welcome to the Rancho Mirage Library and Observatory. My name is Eric McLaughlin. I am the astronomer here, being helped out online by a number of people, including our wonderful observatory coordinator, Lauren Zuckerberg. You might find a few other library staff online here at the moment. There's about 178 of us here online looking at this right now, so we're going to be jumping in really quickly. But before we do, I want to give a special thank you to the Rancho Mirage Library and Observatory Foundation. It is through that foundation that we're able to offer events like this, and especially in this time, it's really nice to be able to get everyone together, at least virtually, to take a look up at the nice night sky. So again, a thank you to the Rancho Mirage Library and Observatory Foundation. Now, as we are getting going here, there are a few things I would like to note. It might actually sound like the sound might cut out here and there. I'm using a push-to-talk system on the microphone. I want to make sure you aren't hearing every single mouse click I'm doing, so I want to make sure you can hear just me when I'm talking and when I mean to actually be giving you that information. And I'm also working with a lot of different systems here, so it's going to be a time that might have a few little pauses in it. So just keep that in mind as we're getting going. See, we got a number of first-time people getting here, so again, welcome. Glad you guys are here. I imagine you might be from any number of places. Looks like we have over 200 people here now, so let's really appreciate you guys all being here right now. Now, what I've got showing for you right now is a view from NASA's Worldview website. It has a few different things, including a nice satellite view. And on that satellite view, we can spot a few really noticeable things. The most noticeable thing here, of course, is actually the fact that all of these clouds here managed to blow out of the Coachella Valley by now, which is wonderful because I was really hoping they'd blow out of the way, and the added benefit is it's nowhere near as hot outside right now while I'm doing this, which makes this much easier to do. So thankfully, we do not have really bad clouds blocking our view tonight. It is completely clear everywhere I look right now, so that is great news. Now, as we are getting going with all this, there are a few things that are also worthwhile to look at. Since our sky is clear, it is nice to be able to actually take a good look up at our sky right now. Here is a quick simulated view of our night sky, and by night, of course, we mean twilight here. And while we're looking at it, it is worthwhile to note what we're seeing in the night sky. We can see the moon, of course, very clearly, but there will also be a nice bright object showing up further west that will become more apparent as the evening progresses, though it will set pretty early. Now, where exactly in the sky are we looking is worth talking about. We got a nice simulated view of the deck here, and we are actually set up with our telescope on the deck right now, and my workstation is right where this simulated view is, right on the center pad of the deck. So this is where I'm talking to you guys from here tonight. And so the moon is way up in our night sky, and by way up I mean very close to straight overhead. And while we're looking straight overhead, we can see a few different details there. Thank you, Claudette. As we're looking up here, let's go ahead and center on the moon and zoom in a little bit. With this setup, we can see very clearly what the phase of the moon is. The moon is in a perfectly first quarter phase, which is really great for looking up at the moon because it gives a lot of detail right along a very specific line. And to get more information on what's going on the moon, I'm going to switch to a different slide here. There it is. All right. So when looking at that particular view, excuse me, I'm getting a little static on the audio. Let me adjust some things. Okay, hopefully that's a little bit clearer. Seems like it may have cleared up a little bit of issue there. All right, so this particular view here allows us to see some really nice things. Still getting a little static. Let me know if you're hearing that as well. Thank you, Joshua. Okay, that might take care of it. There's a little bit of an issue with a lot going on in this computer and having to try to deliver the audio in a very fast rate, so a tiny little delay can take care of some of the static that you might have been hearing. Now, while we're looking at this particular view of the moon here, we can actually note a few things in this particular diagram that are really interesting. Thank you for the confirmation, Jessica. I appreciate that. In this particular view, we can see really nicely this defining line between day and night on the moon. This is what is referred to as the terminator, and that particular view, that particular point is really where sunrise is happening on the moon right now. And as that is right where sunrise is, we can see a lot of shadows being cast there. And we're going to focus a lot of our efforts right near this area. We can actually venture quite a ways over to the day side while we're looking to see a lot of detail, but we'll see the best elevation changes in that region there. Now, this diagram is rather full of a lot of different information. We have a few different things we're showing here, including some current statistics. Yes, it says May 1st down here, but that May 1st setup is really specifically referring to universal time because it's already tomorrow over in Europe right now. And while we're looking down here, we can see current distance to the moon is quite a long ways out there. We're nearly about 30 times the diameter of the Earth all the way out there. This little diagram stretching behind this view of the moon is to scale. So this is the Earth to scale to the moon, and the distance between these two is actually to scale as well. And so being nearly 30 times the diameter of the Earth out puts it at a full distance in kilometers of around 37,000 kilometers. All right, so while we're looking here, we can also see a nice diagram that is quote-unquote top-down up in this region, up on the left-hand corner of the screen. That top-down view is one that, as we look at this diagram throughout the year, the orientation of the Earth-Moon system isn't rotated. It's kept at a fixed frame. This little symbol over here is the symbol for the constellation of Aries. It's referencing the a point that, well, when it was first defined, was in the constellation of Aries. Now it's working its way over into Aquarius, and that is the point where the vernal equinox, or where the direction towards the sun during the vernal equinox. You can look at the lighting on this diagram, and it shows that the sun is not in that direction. Rather, it's up to the upper right of that diagram, making a nice right angle, giving us a half-filled moon right now. But this is a lot of nice, fun looking at diagrams and whatnot, but we're here to actually look directly at the moon. So let's go ahead and transition over to one of our cameras after I make a quick centering adjustment on the telescope. There we go, the telescope is nice and centered, so let's switch over to our live view here. This is a live view from one of our small telescopes. This particular telescope was recently donated by one of our docents, so a special thank you to Bob Corson for donating this telescope. It is a wonderful little telescope, and it'll help us keep a nice, good, wide field view on the moon right now. Thank you, everyone, for the birthday wishes. I appreciate that. Now, as we're looking at the moon here, we can see some really nice features on the moon. Of course, I keep saying that, but I should actually start naming some of those features. And one of those features in particular that is worth pointing out is, of course, the light and dark regions of the moon. The dark regions are known as the seas of the moon, or the mares, or maria, and there are some really good landmarks to find in them, because a number of them really have some, well, places we visited. Of course, the first place we landed on the moon is this area here. This is the Sea of Tranquility, or Mare Tranquillitatis. I will try to say the Latin names when I can say them well enough, but I will probably focus largely on the English names because it's a little bit easier to say, for one thing. Okay, so of course we have the Sea of Tranquility here, making sure I'm not getting them messed up. Up here is the Sea of Serenity, or Mare Serenitatis, or hope I'm saying that right. Yeah, and then we also have the Sea of Fertility down here. Now, when we're looking at places, we have touched base on the moon. The main ones, of course, are to look at the moment here. There are a number of landing sites that are in the night side of the moon, so we won't be addressing them as much, but the Sea of Tranquility has a couple of really important places to note. Towards the southern edge, you have where the Apollo 11 landing occurred, and towards the northern edge is where Apollo 17, the last landing on the moon, occurred, up in this region here. Over on this area over here, near the edge of the Sea of Serenity and bordering the neighboring sea there, right around here is where Apollo 15 landed. Good question. Who names these lunar features? Well, many of them were named long ago. I would have to check the specific names. A lot of the more recently named things were named through the International Astronomical Union, but some of the older stuff would have been named long before that group existed. So that's one thing I'll have to look into specific details for these specific ones. I wouldn't be surprised if and again, I'd have to check this to ensure whether or not Galileo is actually the one who named these specifically, but that is possible. How often do we go live? That's a wonderful question. Right now, this is well, actually, we've had a few different events here. This is our second Swoon at the Moon online, and this is actually the first time we've had two different Swoon at the Moon events in the same month. And while a blue moon is two full moons, or at least one definition of a blue moon is two full moons in the same calendar month, since this isn't a full moon, we're going to call this a blue swoon here. We're hoping to do a lot more in the coming days, as well as we continue through this particular time frame, though. Thank you for your question. Okay, so this is a great little view of the moon here, but I want to actually set up something else for us real quick. Because looking at the nice full disk view of the moon is wonderful, but we also have our main telescope set up and ready to go. You can note it in the lower right hand of the monitor here. This little image right here is actually our main telescope, and you'll notice the door the shutter covering the dome is closed. So let's go ahead and actually get that thing opened up so we can take a good look up at the night sky using that telescope. So I'm going to go ahead and start opening that now. You can see it opening right there. It'll be a little while before we actually get a view through that telescope because the entirety of the dome needs to open fully before I can open the shutters on the telescope itself. Go ahead and switch that view around there. You can see the top of the dome moving at the moment. That shutter will fully open up there, and then we will go ahead and open up the dust covers on the telescope itself, and we'll have a view pointing right up at the moon. How large are those seas, and is there something to reference? Great question from Mark. Is it like the Great Salt Lake or the Salton Sea? It's actually dramatically larger than those seas are dramatically larger than either of those. In fact, much larger than the Great Lakes region in general, or actually maybe similar to the Great Lakes region in size for one of those seas. To give you a nice comparison, let me actually swap over to a different view here. And I will also change this particular view as well. So many different slides, I have to keep them all straight. There it is. So this is the radius of the moon to scale. So when we're looking at the seas of the moon, we're looking at something that would cover an entire state of the United States. The largest one there, it's actually not referred to as a sea, it's the Ocean of Storms. It is completely on the night side of the moon right now. It's facing us, but it's in the shadow of the moon, as it were, and it would cover a significant fraction of the United States, probably even cover all of Texas or all of California and some other states as well. So that's the general scale we're talking about there. Was there ever water on the moon? That is a good question. When we're looking at those seas, yeah, they're flat regions of the moon. There's no water there. Really, it is just flat, low-lying regions that filled in with lava, and that is what made them dark. When it comes to water on the moon, we wouldn't be looking for liquid water, but we can look for ice, and there are some places we might be able to find that. Is the color on the screen when we're looking at the moon the actual color of the moon? As a good question. It should be pretty close to accurate. There will be some camera distortions on color, but let me go ahead and switch us over to a different view right now. This particular view doesn't look all that interesting at the moment, but let's go ahead and look back at our main telescope here. With this view here, now we're ready to go ahead and open up the dust covers on our main telescope. There they go. You should be able to spot them opening down in that lower right-hand corner. Give me just a second while I make some more adjustments. Let me see if I can fine-tune some of the focus on that one. Be just a second. There will be a little bit of an inherent distortion in our atmosphere that will blur the images. As you're looking at this view here, you might be able to actually see some waviness. That is actually atmospheric distortion in our view. Are any of the Apollo landing sites visible? I'll come back to that question in just a few minutes. We want to actually get over to the good view of the moon here. I focused the wrong way, so let me keep adjusting that. Looks like that's about the best we're going to be getting on our focus, and that is just fine. We had a question on the light side versus the dark side versus the far side of the moon, and to address that, it'll take a little bit. I want to look at a few things on this side of the moon before we get going on that particular subject. Wonderful question. Will this be recorded so you can see it again? Yes, as soon as we're done here, it will end up on our YouTube page, and you can replay it anytime you like. To look around the moon, I will be adjusting the main telescope, and one of the fun things we get to do here is I actually get to use a gamepad to actually adjust the telescope over there. So let's go ahead and do that now. First, I need to figure out exactly where we are at the moment. Give me just a second. I'm pretty sure I know, but I want to make sure I end up in the right spot. Alright, we are where I thought we were. We are near on that upper edge. If I can get the telescope to cooperate, there we go. We are looking at mostly the Sea of Tranquility here, and if you want to see the moving telescope, you are actually looking at the view here is from this telescope here, and the telescope was actually moving that whole time here. It's just moving at such a small motion that you wouldn't really notice it there. So why does the moon have craters is another question from Fanny. That is a good question. That particular answer comes from the fact that, well, the Earth also has craters, but the reason why we don't notice them so much is because, well, we have a lot of weathering here. You have various actions from the wind and rain. It has a tendency to wash away those craters, but the moon doesn't have any wind or rain, and as such, it really ends up retaining craters, even very small ones, for a very, very long period of time. So one of those craters looks pretty deep. Some of them can be quite deep, on the order of maybe a kilometer deep or more for some of the larger ones, like Tycho Crater. I'll try and get to a little bit later. It's rather deep, and we're back at that question, are any of the Apollo landing sites visible? We're looking right near where Apollo 11 landed, right down in this region here, and you won't notice it there. And again, to really note why you won't notice it, it is worth comparing again with this view here. You aren't going to notice it because those seas are so large that the context in which we're looking at is still so zoomed out that you won't be able to spot it. However, we can actually look at a few other things to help us get an idea of exactly where those are. To actually see those landers, well, you'd have to actually go there. And in fact, we do have a view of the moon from spacecraft that actually went there. So let me switch off that view and pull up this one here. Okay, so we have a nice map view of the moon here. So once again, we have the Sea of Tranquility here, and if you're looking here, well, you might not notice really where the landing site is. And let's go ahead and zoom in and we'll find that particular landing site here. It's actually down here in this detailed rich region here. Let me know when you see the lander. I'll just keep on zooming in on it. Oop, lost it there. Zoomed a little awkwardly in this browser. The landing site is right in that nice rectangular strip right there. Where is it exactly? Well, keep looking and we'll eventually find it. Do you see it yet? I don't, but I know where it is. That right there is the descent module of Apollo 11. If you look closely as we zoom in a little bit more, we can see a little more detail at the landing site as well. From this view, you can actually see some little trails from where the astronauts walked around. You can actually see a couple of experiments that were set out. Unfortunately, it's not easy to spot the American flag. I actually don't see it. It should be, if I remember correctly, up on this side of the lander. But again, it's a little hard to spot as we're looking straight down on this spot. If that particular flag managed to survive the liftoff thrust from the ascent module, then we'd be looking straight down on top of that flagpole. Even if it did get knocked over by that thrust, though, it would be very difficult to spot. If you can see it, good on you. So once again, this is a very, very magnified view of this particular landing site. So if we go ahead and zoom back on out, all the way back on out to roughly what we were seeing with the main telescope, we're looking somewhere, not quite that far out, right around here. So if we actually switch back over to our other view, you can actually see, again, the landing site would be roughly down here. It's rotated. This image is rotated a little bit relative to that map, so you'll have to do that rotation in your head here. Now, switching back to the small telescope view, make some adjustments while we're doing that. In this particular view, we can actually, again, see a lot of context of what we're looking at. This particular view gives us a view only of the near side. We can see what could be called the dark side, the shadowed side of the moon, and that is really the best and most accurate way to refer to a dark side of the moon. But there is another side of the moon, and that is the far side of the moon. And if the telescope will, there, it's cooperating now. All right, and if the telescope will cooperate, we can get a good view of this whole disk here. Now, again, if we're talking about a light side and a dark side, that would really be the best way to describe it. However, we never get to see the far side of the moon, the side that is facing away from the Earth. And that is because the moon is tidally locked. And we can actually take a good look at what tidal locking looks like by actually doing a bit more inventive things here. By pulling up another view here, we've got a nice view showing exactly where the moon is in the sky. It is hanging out right near Gemini over here. And one of the nice things about this particular program is we can be unconfined by this little sphere we are on called the Earth. We can actually go and get a closer look at something like the moon. Here we are at, might have a little bit of an issue with the button I chose to be my push to talk button in this program. Just a second. I need to find a key that this program doesn't use. Okay, I think we got it. Yeah, we're doing better now. Good. All right, so we're looking at the moon quite nicely here. And with this setup, we can actually take a lot of good views of the moon. We can actually revolve around the moon here, and as we zip around the moon to the far side, we see a very different looking moon over here. There aren't many seas over here. There is just one main one. Oh dear, it's moving without me. Back under control, okay. Now from this view, we can see the Earth hanging out nicely behind the moon from this particular angle, and we can actually have a lot of fun with this by actually adjusting the flow of time. All right, here we go, moving on into the future. Now, as the time accelerates here, you can see that the Earth is rotating substantially while the moon is staying in a locked position from this perspective. Now, that doesn't mean the moon is not rotating. It is rotating at the same rate in which it orbits the Earth. Oh, there's too many orbits there. All right, so as the moon orbits around the Earth, we actually get to see only one side of it because it rotates at that same rate. So as it is rotating from this particular perspective, you can tell it's rotating by actually looking at the background there. That is the more, not exactly stationary view, but that is everything that is much further away from us and as such seems to be stationary. So clearly the moon is rotating with respect to that background now. And in fact, if I turn off rotating with the object, still turned on for some reason. Alright, so it's fighting with me. In any case, it is rotating at the same rate at which it revolves around the Earth. And we can actually look at this from a different perspective to get another viewpoint on that. But for that, I'm going to go ahead and bring us back to normal flow of time and back to the present as well. There we are. And let's go ahead and get a different perspective on things here. We are now pretty well up above the North Pole of the moon. And as we head up this way, let's go ahead and turn the orbit of the moon back on. And I also got things a little flipped around. We are actually not above the North Pole of the moon. we were above the South Pole. Do some quick rotations here. There we go. Now, as we fly on off, we'll get a different perspective on things. Here, the green line you see is actually the orbit of the Earth. We're moving in this direction here. The moon is moving counterclockwise around us, and you can actually see that the moon just really recently passed right over the line that would be the orbit of the Earth, and thus, if this is the Earth's orbit, the sun is right off the top of our screen, roughly, and that is why we end up with a half-lit moon here, because again, if we zoom back in, we can actually see the half-lit. I apologize, we just... Okay, we're back. Sorry about that. I crashed into the surface of the moon, so it freaked out. We should be fine. I apologize if there was any flashing there. Got a question. Does the sun rotate? Yes, it does, but it doesn't rotate like a solid body. The Earth rotates at a given rate no matter what latitude you're at, likewise the moon. However, the sun, being a big flaming ball of plasma, it actually can rotate at different rates at different latitudes. The equatorial regions of the sun actually rotate a bit faster than the poles, and that's really important for what is called the solar dynamo, the thing that actually drives all sorts of solar activity there. Give me just a second while I get our ship back up off the ground here. There we go. Alright, so while we're looking at the moon here, again, there are some really neat features to swing around and take a closer look at. There you'll notice on the right side of the moon here, there are some other markers there, all beginning with the moniker LM, that is for Lunar Module. And in this program, it's not exactly true to life as it is right now because they left the Ascent module, the part of the lunar landers, still on the spacecraft there. So we're going to go ahead and fly on in and take a look at one or two of those as viewed here. I really like visiting Apollo 15's landing site, so we're going to head there. Which planetarium program am I using? I'm using a few here tonight. This one right now is SpaceEngine. You can get the previous version for free on the SpaceEngine website. You can also find it on Steam, which is a program hosting site mostly for video games. All right, let's rotate back around to the Earth-facing side. And as we do so, the North Pole is now moving to the left side of our view here. And here we are. All right, I really like visiting, again, the Apollo 15 landing site because it was the first site that actually had both a lunar rover and it was really tucked away in a rather mountainous region. So that lunar module is the Falcon. So we'll fly on in there as carefully as I can, so I might be a little silent while I'm flying in to make sure I don't crash. Whoops. Did not mean to look straight down. I apologize. There we are. Let's head back over to that lunar module right down there. Get the appropriate orientation so we're not upside down. And there's simulated lunar surface here. All right, there's Falcon. Wrong button there. Asked to say hi to Amanda and Skylar. That's great to say hi. I hope you guys are doing well out there. Hope you're having a great evening, enjoying our time here, exploring a little bit of the moon here in a few different mediums. Make sure I'm clicking on the correct thing here this time. Good, okay. Now, with this particular module locked into place, we can actually look around in this particular region and get, again, a simulated view of what some of the astronauts at that site would have seen. Way too fast there. Slow it down. Now again, I love this particular landing site because of where they landed. It is right in with a whole bunch of hills and other features. And one big important feature is that thing on the left side of the screen. That feature right there, that canyon, is a rill, and that particular rill is the kind that likely formed from a collapsing lava tube. And those are really interesting because if we can find some openings to some non-collapsed lava tubes, those might be really interesting places to potentially try and build a habitat that would be well protected from radiation and other environmental hazards like micrometeoroids, but it also would be one of those places that could be very, very cold and might actually have some water ice in it that we could potentially mine and use for other things. Now, this site is great to see in this particular program, but there's another view that is a little bit more informative, and so I want to switch over to that program really quickly. What are the snaking looking things? Those particular things, let me get a better view of it here really quickly. There we go. That little canyon that snakes by the landing site there is likely a collapsed lava tube. And it is one that, again, it's amazing that they were able to land so close to that site. On the scale of things, at the moment, this particular view, it looks like they landed right next to it. Well, if they didn't have a lunar rover, they might not have been able to actually trek far enough to see it. If you compare this site with the site we were looking at for Apollo 11, well, it was a really small area that Apollo 11 actually explored. To give you an idea of where Apollo 15 actually explored, I'm going to switch views again here. There we are. And in this view, we can actually, again, trek our way over there to Apollo 15's landing site. You can see another Ryle on the lower part of the screen there. Or, sorry, Ril. Can never get those names right. Now, let's see. We should be up near Apollo 15's landing site now. Let's go ahead and zoom on in. See, had a question about where the Big Dipper was when they landed. I'd have to check specifically what particular time frame. We might actually be able to do that really quickly when we switch back over to the other program, but I want to show you exactly where that landing site was and how far they traveled over at Apollo 15's landing site. This is, again, a particular map that we were using to look back at Apollo 11's landing site. But this particular software, it's actually a website. It's NASA's Trek website. You can use it for all sorts of things. You can actually even use this to generate little VR tours of the moon. If you were here actually for our Apollo 11 50th anniversary landing, we did use this program to actually generate some VR sites. And had another question on there about this little crater down at the end of this one. Did this crater contribute to the collapse of that lava tube? Couldn't tell you. I don't know. It may have been there before the lava tube. It may have been there after. Most likely came in after the fact, and I wouldn't be surprised if it actually had something to do with the collapse, but that is something I am unaware of. Now we'll go ahead and pull this up here and get some info on Apollo 15 and see a nice view of where the rover was parked by the RIL itself, and we can actually add a whole bunch of things to our view here with this system. And what we have here is actually the tracks of the rover. You can see how far they went. They went on 3 different EVAs, here color-coded nicely for us. And if you come and visit this site again on your own time to see a lot of things, you can get a whole bunch of little tidbits of information about each of the sites, or each of the little points of interest there. And it's always nice to get a nice view of what actually happened there. That is a real picture from the landing site there. Again, the first landing site that was in a really rugged region, and the first one to include the lunar rover. So it's a wonderful, wonderful little landing site to take a quick look at. Now, going back to that question of what was in the sky when they landed, let's go ahead and switch back over to the other program. And with this program, we can go ahead and land back at the surface there. All right, so this is the view from that landing right now. Or, you know, close enough to it. And one of the things you'll notice right away is the Little Dipper right there. With the Little Dipper so nicely highlighted right here, that is Ursa Minor. This particular point here is where the North Star is. And so let's see how things look if we advance time. Here on the Earth, we have a nice point here where that star there, Polaris, the North Star, doesn't move in our night sky. However, you'll notice that point actually moves on the moon. That is because the rotation axis of the moon is not aligned with the rotation axis of the Earth, so a different point in the sky is where the sky rotates about on the moon. And while we're looking up, we can actually see it is over here near the bend in Draco at the moment. Right here is Draco, and you can see it's rotating right around the back of Draco's neck there. But what did the astronauts see when they landed at this site? Well, this particular site, I need to double check the specific date in which they landed there. Because I don't have that memorized, unfortunately. Alright, there it is, July 30th, 1971. So what we can do in this program is we can actually time travel back to that day. We are now back when they would have been at the surface of the moon there. And we want to get a good view of what they saw in the whole night sky, so we can actually adjust some things here. So one of the things to note about that particular landing site is where it was on the moon. It was in a spot that isn't too far away from where can be directly below the Earth, as it were. That is, the Earth would be almost directly overhead, as we can see in this particular view here. Now, this is all well and good, but I want to take one more quick look back at the moon because, well, we're here to look at the moon actually, not just talk about it virtually. So let's swap back over to our small telescope view. Now back over at this particular view, again, this is the Sea of Tranquility here. We were looking very closely down here at the Apollo 11 landing site. And the Apollo 15 landing site was up here. And I want to swing down right down in this region with our main telescope in just a few minutes because I want to actually look at some of those big craters down there. All right, here we are back at the moon. Why do they call it the Sea of Tranquility? Again, the term seas there come from the fact that when they looked at them initially, they thought they actually looked like bodies of water. And so those big dark regions, actually we'll go ahead and swap back over here, those big dark regions of the moon were called seas because of really a lack of knowledge. But when we actually figured out they weren't seas, the name stuck, and they're big flat basins in any case, so it works out well enough. The Sea of Tranquility, specifics of its name, how it got it, again, I'd have to check and see who it was that actually named that particular sea. Unfortunately, that note isn't something I know off the top of my head. Back to the big telescope, let's go ahead and adjust around and find some really nice craters. Is Venus close to the moon tonight? It's a good maybe about, well, maybe 40 to 60 degrees west of it. Venus is the big bright object off towards the west. A few nights ago, they were quite close together, however. Am I using a lunar filter? Actually, no. These cameras are actually just have their exposures tuned such that they aren't being overexposed with the moon right now. They're very short exposures. Did the Chinese rover land anywhere near the area we're looking at now? Depends on which rover you're talking about. One of the rovers, they actually landed on the far side of the moon, so we will not be able to see it with our telescopes here. We'd have to go back in some of the programs and look at the far side of the moon that way. Now let's see, someone mentioned a straight wall feature. Did I actually skim off of that? Let me see if I can get back to it. Or rather, is it that line on the left? Now, those rills I mentioned, those collapsed lava tubes for the really curvy rills, that is one feature you can get. It looks like we might be actually looking at another kind of rill right here, this very straight rill. And one type of rill that ends up very straight is actually the result of not collapsed lava tubes, but rather tectonic activity. They're things that can actually happen here on the Earth, but they aren't that noticeable. And what it is it's also referred to as a graben, or a grabon. And what that is two faults that are parallel to each other that have moved away from each other, and the in between them there's a little bit of land that sunk down, making a nice little canyon. So that might be what we're looking at there. I'd have to double check. Might be a different feature though. But nevertheless, that is the kind of thing you can see with those types of rills, is really good straight lines. All right, why is there so much more of a density of craters in some areas rather than others? Well, one of the things to note is, again, the difference between the seas and the rather telling name, the highlands. Where you find a lot of craters like this is the highlands, whereas the seas actually refer to areas that are lower lying that actually filled in with a lot of lava and sometime in the ancient moon's past. And as it filled in with lava, it covered over a lot of those really large craters, making it actually less cratered relative to the highlands like what we're looking at now. And so that's why you don't see as many really big craters in the seas, because they used to be there, but they got covered over. Now, of course, adjusting that big telescope with a video game controller, it takes a little fine touch, so I'm trying to get to a very specific spot, so give me just a second. All right, had to check my map to make sure I knew where we were looking. Yes, we are looking where I think we are, and there's a really particular crater that ends up being really a nice feature as the month goes along. This little thing right here, this dark rimmed crater here, is Tycho Crater. It is on the order of around, if I remember correctly, just under 90 kilometers across, and it has a nice central peak that over the coming days will probably peek its way through the darkness into the light before the rest of the crater itself gets a lot of sunlight on it. But it's really a nice crater to spot because as the sunlight ends up hitting a little more keenly straight down on that crater, you'll notice a few other things, and you can actually spot some of it here. You can actually see some sort of stripes radiating away from it. So Tycho Crater is a relatively recent crater relative to the others, and it spewed a whole bunch of material out of it in a very radial fashion, and that material ends up being a slightly different color in the surrounding region around Tycho Crater. So it's always a cool thing to spot Tycho Crater. Oh goodness, so many questions. So yeah, you may have noticed in some of the craters, you might see a little bit of a peak, and that is a rebound of the surface. As something smashes into the moon, the actual surface can have a tendency to rebound up, just like if you throw a stone in a pond, you'll see the water splash up in a very nice fashion if it's the right size stone, making a central peak. And unlike water, stone has a possibility to actually get stuck that way as it cools off. And so that is what can cause a bit of a peak in the center of some of these craters. Let me see if I can find a good example of one here. There's a good example right in the center there. That is a central peak from the impact itself. You can even see some of the others have some central peaks as well, so that one stands out really well. And that is something that is pretty common with larger craters. If they get big enough, well, that's another story, but it needs to actually be a significantly sized one to have the central peak. But if you get too big, the central region will probably be liquid long enough to not have a really, really big central peak. So anyway, random question about a few different things here. Let's see. What kind of controller is it? It's a Logitech controller that's a knockoff of a PlayStation controller in any case. Is the moon divided into tectonic plates like the Earth? I have to check the specifics of it. There are faults on the moon, and while you can have faults, it doesn't necessarily mean that they all interconnect into a whole bunch of plates. So I'd have to double check, but there are faults, so there is tectonic activity in that sense. But whether or not it's all divided into plates, I'd have to double check. Okay, so one quick question came up about where are we landing the Starship? Well, that is a fun note. If you have your eye on the news, you may have seen that NASA actually recently announced a set of contracts for building lunar landers. And among them are proposals to actually build a lunar optimized version of SpaceX's Starship. So SpaceX got the contract, as did a group of companies that include Blue Origin, ULA, Lockheed Martin, and others are all working together to build a 3-stage lander. And then I believe it was Dryden Aerospace that is working on their own lander as well. That is very different than the others. It is also a 1-stage like Starship, but it has a very low to the ground crew cabin, which makes it relatively easy to get in and out of compared to every other design that tends to be made for lunar landers. So it's really an interesting thing. I highly recommend checking out NASA's announcement on that. And I think we're ready to go ahead and, let's see, with the earthquake equipment, or the equipment left behind, did they detect, or did they put a seismometer there? Yes, there have been a number of seismometers there. The first one was actually taken by the Apollo 11 mission. However, that one didn't last very long. Thankfully, many of the others that have been put there have lasted much longer, and we do detect moonquakes. Among the times we detect moonquakes are, of course, meteor impacts, and actually also right where we're looking right now, right near that terminator line, there is a dramatic change in the temperature of the material, and the entire surface actually groans a little bit with that. And so right near sunrise and sunset, there is always a little bit of a moonquake. It's going to be very minor, nothing like what we felt a few weeks back here in the Coachella Valley, probably much more minor than that. But there's likely other moonquake activity as well. I believe they've detected a few other things, but I'd have to double check that. Let's see. I want to touch base on a couple of other things. We've had some really great views of the moon, but last month, rather the beginning of this month, I mentioned to keep an eye on Venus. And I want to go take another look at that. And any trace of water found on the moon, thank you for reminding me. I was actually going somewhere before when I was talking about lunar landings and future ones. And that actually had to do with that question. Where are we landing the SpaceX spaceship and all the other things? Well, they're going to likely be heading towards the south pole of the moon. Let me go ahead and navigate us down there. Now, it'll be very difficult for me to point out exactly which of these craters down here is Shackleton Crater, but there is a crater called Shackleton Crater. It is right near the south pole of the moon, and as a crater is a big old divot with nice high walls around it, if you put that at the north or south poles of a planet or moon, you can actually have basically perpetual night in there, and Shackleton Crater is one such crater, and we have detected water ice down there, and that makes it really a interesting place to go visit. And so the south pole of the moon is one of the places we will likely be sending humans on the next few missions. It is a very interesting place. It is very much so in the highlands of the moon, so thankfully we've done a little bit of exploratory work figuring out how to land in the highlands back in the Apollo era. So trying to land there is something that will take a little bit of relearning, but mostly really just moving forward with a lot of things. Though it is worth noting that it's still very difficult. The Indian Space Research Organization, ISRO, recently tried to land a lander there, and unfortunately there were some issues shortly before it touched down, and it did end up crashing. However, they are aiming to send another probe, another lander there, using the same design, correcting the issues they had, and hopefully they'll get that one up before too long. Why the South Pole? Again, because the crater there actually can have perpetual night in it. That is specifically, well, a number of the craters, but specifically Shackleton Crater is right near the South Pole, and as it has no sunlight falling on the bottom of that crater, there is some accumulated water ice that is very useful for not just surviving, but also for making things like rocket fuel and other such like that. Now we got, does SpaceX collaborate with NASA, or is it separate? SpaceX, by and large, is largely contracted by NASA, and in fact, again, they just won this lander award, and they recently won a contract for a Super Dragon that will go and what's the word? Resupply the Lunar Gateway, a space station that is proposed to be built over at the moon. And really excitingly, before the next swoon at the moon, we will hopefully have launched astronauts from American soil using a SpaceX rocket, and it will be the first time Americans will have launched from American soil since the end of the shuttle era back in 2011. So that is scheduled for March 27th using the Dragon 2 spacecraft aboard on top of a Falcon 2, or as far as Falcon 9, Dragon 2, Falcon 9. And so really excited for May 27th. That should be a really exciting time. Does the moon have any kind of electromagnetic field? So the Earth has a wonderful magnetic field. However, the moon doesn't have a really strong one, which is the kind of thing that indicates that the interior of the moon might be a bit cooler, but it will have a little bit of a magnetosphere, though it's not all that impressive, especially compared to the Earth. All right, now I promised we were going to go visit Venus, and I want to do that. Before I do that, I want to give a little perspective on some things. So give me a second to get back there. All right. Back to SpaceEngine here. And with this particular view, we can see the moon again and Venus as well hanging out just below Auriga, that funny little pentagonal shape there. And by pentagonal shape, I'm referring to this shape here. That is Auriga. This is Taurus down here, Orion right here, and Venus hanging out right there is a really cool thing to see. And one of the fun things we can do with it is we can go ahead and center it. And zoom in on it nicely from here. As we zoom in here again, you can actually see there is a nice crescent shape to Venus right now. And that is because, well, from our perspective, Venus does experience phases. How does it experience phases? Well, let's take a look. The phases of the moon are really specifically easy to see because, well, the moon is very close by and the moon revolves around the Earth. And so we get to see a full set of lighting on the moon. Venus is in another position that gives us an opportunity to see some phases as well. Let me go ahead and show you that more specifically. We'll leave behind the Earth really quickly. There's the Coachella Valley, all nice and lit up in here. Okay, so I'm going to have to do some quick orientation adjustments to get us over not the North Pole, but rather perpendicular to the plane of the Earth's orbit. I see questions about, did I say March 27th? I meant May 27th for the next launch, and that is this year. The 2024 is the targeted landing date for the next moon mission. The Artemis project wants to land people on the moon in 2024. The specifics of that date are not yet established, but one of the things that is really special about that is it will actually be the first time we send not just men but women as well to the moon. We want to have the first woman landing on the moon in 2024, and hopefully in a way that allows us to build a more sustainable presence there. So I'm going to make those adjustments on our view here so we can actually get a more specific view over at understanding Venus's phases. Alright, so we are positioned once again over, quote unquote, the Earth-Moon system, over the plane of the Earth's orbit, and now let's go ahead and back away until we can actually see more of the format of the solar system itself. Or rather, the current orbital setup of everything in the solar system. There we are. Now, from this view, we can see quite readily how we actually have the Earth here, the Sun here, and this right here is Venus. And so, from this particular viewpoint, the Earth is moving in a nice counterclockwise fashion, as is Mars, as is Venus, as is Mercury here. And as these things move around, well, we can only see the sunlit side of Mars because it's always outside our orbit. However, as Venus moves in between the Sun and the Earth, we actually get a view of the night side of Venus, and as such, we get to see the phases of Venus in a similar way to which we see the phases of the Moon. However, we see them in slightly different orientations. Normally, when we see a waning moon, that is visible only during the mornings. That is a moon that is getting less and less full. Right now we are seeing a waxing moon. The first quarter is really when we actually have the moon going from a waxing crescent, getting full until being half filled, and then it will go to being a waxing gibbous, then it will be a full moon, and then it will start getting more in the shade. That is, it will head towards a waning moon. We see waxing moon in the evening hours, and we see a waning moon in the morning hours, at least especially rather with regards to the crescent phases. With Venus, you see the waning phase of Venus as it exists as the evening star, and it will be waxing as the morning star. It's reversed in that regard. And how does that actually work out? Well, again, in this particular setup, we are looking at Venus as it is in a nice crescent phase, and it is getting less and less full. While if we advance time a bit here, really nice and quickly, Venus overtakes us in its orbit, and it goes from being a waning crescent as it passes in between us and the sun. It is completely dark, basically, pretty close to it anyway, and then it's actually so close to the sun we generally just don't see it. And then at this stage, as is shown here, it would be a waxing crescent. Likewise, Mercury would also be a waxing crescent in this particular viewpoint. However, because it is so much smaller and so much more distant, we tend to not really see it that well unless you have a very, very high magnification on your telescope. So that's enough talking about looking at Venus. Let's actually look at Venus here. So let's get our big telescope view up, and give me a minute while I make the adjustments. I don't want to send the telescope over there too rapidly because it will have a tendency to, well, rush past the target if I do that with the internet connection I'm using to control it. So give me a moment to send it over there. Sorry, I'm not sure how much you weren't able to hear there. I think we had a question. Yeah, thank you for letting me know about the lack of audio there. Sometimes if I'm in a different program, the mic doesn't like to turn on. So yeah, I was talking about the moon. Is it visible from the poles? Yes, it is, because the orbit of the moon, the plane of its orbit, is not aligned with the equator of the Earth. And so for half of the moon's orbit, it'll actually stretch up into the sky no matter which pole you're at. For about half of the moon's orbit, it will be visible. Should be able to hear me now. Double check that we can actually communicate right now. All right, thank you. Again, when I click into certain programs, for some reason it likes to turn off my audio, turn off the mic, so thank you for catching that. All right, so now we're looking over at Venus. Let me adjust some settings because it's a little bit oversaturated there. It is down near the horizon, so it is really in a lot of atmosphere, and so that's why it's shimmering so much over there. All right, so there we are back at Venus. And if you were here, okay, you should be able to hear me now. If we were here back at the beginning of the month, I said keep an eye on Venus. It should be brighter now than it was then. And in fact, it is substantially closer. Now, last month, I was using a different camera on our main telescope that had a lower magnification, so that magnification has changed by a factor of, I believe, about 2.5, so we're a bit more zoomed in now. But even with that, Venus is now so much closer that if you have been keeping an eye on it in your telescopes, it will physically be larger in the field of view. Now, with that quick visit back to Venus, it's been wonderful going through all these different things with everyone. I went a lot longer than I expected to. So what I'm going to do now is start closing everything up, and we'll sign off here in just a few minutes. But as we do, I want to again say thank you to all of you for being here. It has been a wonderful fun time hanging out with all of you, exploring a little corner of the universe here tonight. We hope to do a lot more here in the near future. And again, keep an eye on everything here. If you liked what you were seeing tonight, and you want to be kept informed about when we have these things, feel free to sign up for our e-newsletter at the Rancho Mirage Library and Observatory website. You can sign up for all sorts of things on there. It really helps us keep in touch with all of you. If you want to be kept directly informed when we have different things going on online, you can subscribe to our YouTube page right here. You can also get some notifications turned on there. But again, thank you all for being here. Really appreciate all of you. And a special thank you to Lauren and the others at the Rancho Mirage Library and Observatory who are helping out tonight, as well as our docents who always help us out with so much. And again, finally, a special thank you to the Rancho Mirage Library and Observatory Foundation. Without them, we would not be able to do things like this. So again, I hope you had a wonderful time here tonight. It has been fun chatting with you and exploring. And again, I hope you have a wonderful night. Have a good one. Good night.